Good morning. My name is David Johnson. Today I'd like to share a presentation with you about why Pluto is not a planet. Here's the order of things. First, I'm going to walk you through the order of discovery of the known planets and dwarf planets. Then, we're going to look at the definition of a planet and a dwarf planet according to the International Astronomical Union, which is the generally recognized authority on the naming and classification of planets. And then, using these definitions, we're going to classify Pluto. We're going to find that Pluto does not meet the definition of a planet, but it does meet the definition of a dwarf planet. Let's look at these planets right here. These are Mercury, Venus, Earth, Mars, Jupiter, and Saturn. These are the planets we've known since prehistory. Since the invention of telescopes, Uranus was discovered in 1781. You may think that Neptune and Pluto are next, but actually, Ceres is next. And this is an object that is located in between Mars and Jupiter. It was originally thought of as the 8th planet, but after the discovery of Pallas, Vesta, and other objects, it was declassified into a new class of objects called asteroids, and these objects are all in the asteroid belt. After that, Neptune was discovered in 1846, and then finally, our good friend Pluto was discovered in 1930 by Clyde William Tombaugh. It's located beyond the orbit of Neptune. It was initially classified as the 9th and final planet because it was the last planet-sized object to be discovered until 2004. When the Palomar Observatory in California discovered these three objects, Haumea, Makemake, and Eris, between 2004 and 2005. Since these were of a similar size, composition, and orbit to Pluto, the question was, are these going to be considered planets too? To answer the question, the International Astronomical Union decided to hold a General Assembly in Prague in 2006, where they decided on an official definition of a planet and a dwarf planet. According to the IAU, a planet is a celestial body that is in orbit around the sun, has sufficient mass for its self-gravity to overcome rigid body forces so that it assumes a hydrostatic equilibrium or nearly round shape, and has cleared the neighborhood around its orbit. And a dwarf planet is a celestial body that only meets requirements 1 and 2. The first requirement is that a planet must orbit around the sun. Planets that orbit other stars or planets that do not orbit stars at all aren't counted. And also, objects that orbit around planets, like moons, don't count. However, the length of time that an object takes to orbit around the sun, the shape of the orbit, and how far the planet is from the sun do not matter, as long as it does orbit the sun. The second requirement, which is a bit complicated, is that a planet must have sufficient mass for its self-gravity to overcome rigid body forces so that it assumes a hydrostatic equilibrium or a nearly round shape. What this means is that if you start off with a homogeneous mass of different density materials, eventually it'll collect into a spherical shape, and the different materials will separate out depending on their density, with the more dense materials in the center, the less dense materials on the outside. This is what you see in planets like Earth, which has a dense solid core, and then a less dense mantle, and then a less dense crust. And also in larger planets like Jupiter, which has a solid icy core, but then also a gaseous exterior, which is less dense. Objects above a certain size will be gravitationally rounded, but this depends on their density and material. Mimas is the smallest gravitationally rounded object that we know of. It's a moon of Saturn, and it has a density of 1.15 grams per cubic centimeter because it's made out of ice. While Vesta is the largest non-rounded object that we know of. It's in the asteroid belt, and it has a density of 3.5 grams per cubic centimeter because it is made out of rock. Notice that Vesta is considerably larger than Mimas. Meanwhile, objects in hydrostatic equilibrium have the internal composition such that gravitational forces throughout the planet are canceled out by pressure. It's difficult to tell if an object is in hydrostatic equilibrium without information on its composition, but usually we assume that objects that are large enough to be gravitationally rounded are in hydrostatic equilibrium until it's proven that they're not. The smallest object in equilibrium that we know of is Ceres. Iapetus is the largest object not in equilibrium that we know of. It's another moon of Saturn, and notice that it is considerably larger than Ceres. This way, we can consider objects like Haumea, which, because it spins so quickly, is almost twice as long as it is wide. We can assume that it is in equilibrium, even if we don't have evidence on it, because it is of a certain size. The final requirement is that a planet must clear the neighborhood around its orbit. When other objects enter its orbit, they must do one of the following. They must be captured by the planet and become a moon, or crash into the planet, or be ejected by the planet's gravity, or be forced into co-orbit, such as a Trojan. A Trojan is not found often, however, some planets have them. They are objects that orbit either 60 degrees behind or ahead of the planet. It's a result of both the planet's gravity and the sun's gravity, forcing it to orbit in a specific location. That's outside of the scope of this presentation, however. Now let's classify Pluto. Pluto orbits the sun, so it satisfies requirement 1. It has been proven to assume a round shape due to gravity and is in hydrostatic equilibrium, so it satisfies requirement 2. However, both Pluto and Makemake are located in the Kuiper belt, which is a belt of objects beyond Neptune, where no one single object is dominant. It's like the asteroid belt in that regard. Likewise, Eris and Haumea are both in the scattered disk, another region like the Kuiper belt with many objects in which no one object is dominant. Since none of these objects are massive enough to eject or accrete the other objects in the belt, none of them is gravitationally dominant, therefore, none of them meets the third requirement for being a planet. Therefore, the IAU decided in 2006 that Pluto, Ceres, Makemake, Haumea, and Eris are all dwarf planets. What happened to Pluto is similar to what happened to Ceres in the 1800s. Ceres was originally thought of as a planet until similar objects were found in its orbit, and it was demoted to a new class of objects called asteroids. Pluto was originally called a planet until similar objects were found in the Kuiper belt along with it, and it was demoted to a dwarf planet, but also put in a new class of objects called trans-Neptunian objects. Finally, I want to mention the demotion of Pluto is still unpopular, particularly in America where Pluto was discovered. It's both a cultural and an emotional thing to think of Pluto as still being a planet. Everyone I've talked to while researching this presentation said they still think Pluto is a planet. But it's important to understand that as scientific knowledge changes, our opinions about it have to change. More trans-Neptunian objects are still being discovered, and it's possible Pluto may be reclassified again. So we have to keep an open mind, and we have to remind ourselves that the universe is still being discovered. And we may only have 8 planets, but we know about more objects in the solar system and the universe than ever before. So now is a great time to go out and learn more about it. I want to appreciate you taking the time to watch my presentation. These are my works cited. You may find these in the description if you would like to research them yourself. I appreciate your time. Have an excellent day.